together. So basically you're finding the dimensions of the length and the width and you're multiplying them together. So for this rectangle A, on the right, on the leftmost side, you can see how the length is 1, 2, 3, 3 squares, and then the width is 1, 2, 3, 4 squares. So if you multiply those together, you get 12 square units. And so thus is the formula for area length times width.
So this picture has a area of 80 centimeters. So this time we can do the reverse. Since we know that area is length times width, we have the area and we have the length. We can plug in the numbers. So 80 as area, 10 as length, and the width is still unknown. And then we can divide both sides by 10 centimeters, which is the length, to find that the width is 8 centimeters long. Okay, so perimeter.
Okay, perimeter. An introduction to perimeters. So the perimeter is basically the length of the outline of the figure. You can easily find the perimeter of a regular polygon, which is a closed figure with equal sides, by finding the length of one side and multiplying it by the number of sides the shape has. So if you look here, these are some examples of regular polygons.
So let's look at this shape. So we're going to find the perimeter of the shape by looking at the sides and then just count the unit squares you see below. So each square is 1 by 1 centimeter. So just find the perimeter of this. 4, 8, 9, 11, 14, 15, 18, 19, 5. Okay, so here we know that so we just count each one of the sides is 1 centimeter. So we just add them all up, and then the perimeter is 24 centimeters.
Okay, so areas of parallelograms, triangles, and shapes on grids.
So I'm not sure my computer sound. 1 second.
Hello, everyone. So this week's video, I should say, is going to be about the area of parallelograms, the area of triangles, and the area of shapes on a grid. So let's just start with triangles because it is super easy. So if we just search up area of a triangle, I'm pretty sure all of you know it, but we can go over it too. So as you can see, this is the triangle that they're giving us. And the area of a triangle, this is another way of saying, many of you know, half times base times height. So what they're saying is, in order to get the answer, you have to do 1/2 times the base. The base is this portion right here. That will go right here. And then times the height. And the height is this portion right here. So right here. And that's going to go. And then once you get that, that's going to be equal to the area of a triangle. And I think that's pretty self-explanatory. Many of you already know, but that's just basically what it is. And the reason for that is actually, if we think about it as a rectangular square. So let's just draw, this is technically a rectangle, but it could pass off as a square if we wanted to be theoretical. So if we make a triangle by slicing it in half, the area, I'm going to type it out, the area of let's just refer to it as a square, just for this topic or lesson. So the area of the square in this instance would be S squared. Let's just pretend that this is side S. And then obviously if it's a square, all sides are equal, which means that this is also side S. And so is this, and so is this. So the area of this square is S squared. And if we were to do the area of the triangle, it would be 1/2 times base, or the base is just S, and then times S. So as we can see, the only difference between these two is that this one is being multiplied by 1/2 because the squared, the S squared stays the same. This is the same as this. So the reason why it's being multiplied by 1/2 is because the square is this entire portion. The square is this entire portion. But the triangle is only this portion. As we can see, that is 1/2 of the square, which is just another way of visualizing the area of a triangle. So this is just another way of sort of understanding that concept. And we can do the same thing for a parallelogram. So this is the parallelogram that they give us. A parallelogram is basically just a square or a rectangle, except it's shifted. So instead of it being like this, it becomes slanted like that. So the area is also base times height, just like a square or rectangle. But the thing that you need to remember is that the base stays the same. The base is not slanted. So this part is not slanted, it's straight. And this part is also not slanted, it is straight. The parts or the sides of the shape that are not slanted are the base. So the area would equal this part, and then times the height. One important thing to remember is that it's not the slant height. That is called the slant height. And if you're wondering why, well, it's actually a pretty easy term to define. It's because it's slanted. You want to take the height that's not slanted. You want to take this height, and we can obviously see that it's not slanted, it's straight. So when you're doing area is equal to base times height, you want to use this portion, so the non-slanted portion. And if you're ever wondering, how do you get that part? Well, if you look here, if you look pretty closely, you can see that this is just a triangle. It's actually a right triangle, which makes it a lot easier, and we can actually use Pythagorean theorem to solve it. So this would be the thing that we're trying to solve for. And then this is going to be connected a large way. So if we already know what this is, like x, for example, and we already know the hypotenuse because that's slant height, so y, then with the Pythagorean theorem, which is a squared plus b squared is equal to c squared, we can use that formula to figure out what the height is going to be, and we can use that in our area. Now, moving on to our last topic, we're going to be using the textbook that we've been using previously for other videos. So what you're going to do is you're going to search up Big Ideas Math Free Easy Access Student Edition. And obviously it's not going to be zoomed out.
Give me 1 second. I'll try and skip the video for a little bit. So also while we're at it.
Hello everyone. So today's, or this week's video, I should say.
So I was wondering if you guys are interested in watching the whole video through, or do you guys just want to skip through it and continue with the rest of the lecture and start on the problems earlier? You can either like private message me or like unmute your mic. Okay, Avery is here. All right, so after seeing you guys do the problems last week, I think that you guys should be fine. So I'm just going to continue with the rest of the lecture and start on the problems earlier.
Okay, so now we're going to focus on the area of trapezoids and other composite figures. So here we have a trapezoid. It's a four-sided figure, or also known as a quadrilateral, where two of the sides are parallel to each other, making it a trapezoid. Only two of the sides have to be parallel to each other. So we're going to find the area of the trapezoid based on the dimensions we have. So just try solving it for yourself and we can go over it together. Okay, so that should be enough time. We're just gonna go over it now. So we can see that the top base, let's just call that base 1, and then the bot is 2, and then the bottom base is base 2, and it's 6 units long. So the formula, as you guys might already know, is area of a trapezoid equals 1/2 base 1 plus base 2 times the height. So you could also say it's like the average of the bases times the height. You could think of it that way as well. So the two bases are 2 and 6. So if we add them together, b1 plus b2 equals 8. And then we can divide that number by 2 or multiply it by half, however you want to think. 8 divided by 2 or 8 times half is 4. And then we can multiply this number 4 by the height, and we get the height over here on the far right side is 3. So 4 times 3 equals 12. So the area is 12 square units of this trapezoid.
All right, so area of kites. So what is the area of this figure? So first try to solve it yourself, and then we can go over there. And this is a Ria's text, but yeah. Anyways, the area of the formula is 1/2 diagonal 1 times diagonal 2. All right, so we know that the diagonals here are given. They're diagonal of the vertices. So it's from this side to this side, it's 14 centimeters. And from the top to the bottom, it's 8 centimeters. So those are two diagonals. Yeah, okay, that's right. So yeah, you can either divide before or divide after, doesn't matter. So yeah, like 14 divided by 2 equals 7. 7 times 8 equals 56. Pulling is correct. Here are the diagonals. Now we're going to look at the area and circumference of circles.
I can do this slide. Okay, so the area of a circle. A circle is just another regular polygon. If you already know how to try solving for its area. You will need to use the circle's radius, which is half of its diameter, and the diameter is the full length across. So you see that 5 meters is the radius, and the pi. So the number pi is a mathematical constant. It is defined as the ratio of a circle's circumference, which is like around, and to its diameter, and it's approximately 3.14. So if you guys, yeah. So the formula for the area of a circle is known as area equals pi r squared. So plug in all your known values. So pi, and then r squared is 5 squared, which is 25. And then if you multiply, you get that the area equals 78.5 meters square.
So the circumference of a circle is referring. The term circumference of a circle is referring to the perimeter of a circle. So it's the length all the way across, around the circle. Sorry, not across. So it's a perimeter of the circle. So let's try solving for the circumference of this circle, and then we can go over it together. You need to use the radius, length, and the constant pi, but with a different equation. So if you guys already know the equation, go for it, try it out. Okay, so you guys should use the formula. If you guys don't already know, the formula for the circumference of a circle is pi r, 2 pi r, or you could also think of it as pi times the diameter, because the diameter is 2 times the radius, and we're just multiplying the diameter by pi. So you could think of it as either 2 pi r or pi d. For this example, we're gonna just use 2 pi r. So plug in your known values and solve. So we know that the radius is 5 meters. So we're going to do 2 times pi times 5. So that gives us 10 pi, because 2 times 5 is 10. So the circumference is 10 pi, but you can keep it like this in terms of pi, or solve it further by multiplying it by an estimate of pi. And we're just going to use pi equals 3.14, and we get 31.2 meters.
So it should be 31.4. It was a typo on the slideshow.
Yeah. Okay. So yeah, 3.14 times 10. The decimal moves one place to the right, and we get 31.4 meters. And make sure to include your units, which are meters.
Alright, so that's it for the presentation today. I'm gonna also stop recording.